Welcome. In this video, we'll be learning about parametric equations. We have graph plane curves that are composed of sets of ordered pairs x, y in the rectangular coordinate plane. Now we discuss a way to represent plane curves in which x and y are functions of a third variable t. Parametric equations by definition is if f and g are continuous functions of t on an interval I, then the set of ordered pairs x, y such that x is a function of t and y is another function of t, is a plane curve. The equations x equals f of t and y is equal to g of t are parametric equations for the curve. The variable t is a parameter. So let's take a look at example 1. Graph the curve represented by the equations x is equal to 1/2 t and y is equal to t squared minus 3, where the parameter t is between -3 and 3. So in order to graph this curve, what we need to do is we need to list the parameters for t. So that's going to be listing t between -3 and 3. To find the x value, we're going to take the t value and plug it into 1/2 t. And that would give us the y values of -3/2, -1, -1/2, and so forth. To find the corresponding y value, we're going to take the same t values and plug it into the equation t squared minus 3. And that will give us y values of 6, 1, -2, -3, and so forth. If you want to write them as an ordered pair x, y, the ordered pairs would be -3/2, 6, -1, 1, -1/2, -2, and so forth. And plot them on a graph, you notice that it looks like a quadratic. To graph a parametric function on a graphing calculator, we need to go under the mode button, scroll down and over to the PAR, which means parametric, then hit enter, making sure that the PAR is highlighted before exiting out. The variable that we're looking for whenever we're trying to graph is the x, t, theta, n button, and that is the variable we're going to use. Now let's take a look at the next problem. It says to graph the plane curve given by the parametric equation, then find the equivalent rectangular equation. So we have x is equal to 1/2 t, y is equal to 6t minus 7, where t is between -1 and 6. If we want to use the graphing calculator, the first thing you need to do is go to y equals, and let x1 be 1/2 t, y1 being 6t minus 7. Then, by using the parameters of t, we go into the window. T min is -1, T max is 6, with the T step is 1. The x and the y changes from problem to problem. If you want to know what the ordered pair looks like, go to the table. In this case, I would have ordered pairs of -0.5 and -13, 0, -7, and so forth. Then from there, you can go to graph to see what the graph looks like. Next, they asked to find the equivalent rectangular function. If you notice on the graph that it is a function of y is equal to f of x. So when it comes to finding the equivalent rectangular equation, we want to rewrite the parametric equation as y is equal to f of x. First thing we need to do is we need to take the x equation and solve for t. That means I need to multiply both sides by 2. And I get t is equal to 2x. Second thing I want to do is I want to rewrite y as a function of x. So take the y equation, 6t minus 7, then substitute in 2x for t. And the equation that we're looking for would be 12x minus 7. If we're rewriting the function in terms of x, that means that we need to rewrite the parameter in terms of x also. So in the step number 3, we want to change the domain from t to x. Your domain for t is -1 less than or equal to t, less than or equal to 6. But now we know what t is equal to. T is equal to 2x. And if we divide everything by 2, the domain for x would be -1/2 less than or equal to x less than or equal to 3. For the next problem, it wants to graph the plane curve given by the parametric equation and then find the equivalent rectangular equation for it. We have x is equal to 4t squared, y is equal to 2t, for the parameter t being between -1 and 1, for t to be between -1 and 1. So if we're going to use our graphing calculator, first thing we need to do is go into y equals, type in the x1 and y1. Next, we got to fix our window. Third, we're going to look at our table, and we're only looking between -1 and 1 for the table part. Last but not least, we're going to look at the graph. And looking at this is actually written as x as a function of y because it's turned on its side. Because it's turned on its side, that means when we look at the rectangular equation part, we're actually going to write it as x as a function of y. So nothing different here. First thing you want to do is, again, we want to take the y equals 2t and solve for t. Second, we want to write x as a function of y. So look at the x equation, 4t squared, and plug in y over 2 for t, and simplify it. X is equal to y squared. If we change the function to x as a function of y, then we also need to change the domain, or the parameter, from t to y. We know that t is equal to y over 2, and multiply both sides by 2. And that would be your new parameter for y. The process stays the same no matter what the equations are given. In order to graph it again, plug it into y equals. Make sure you fix your window. Look at the table. And then look at the graph. Pretty straightforward. Make sure if you are using a graphing calculator that you're in the right mode. The important thing to realize about the graph is how it's written. The reason why it's important to realize that the graph is written as y as a function of x, because when we're trying to find the equivalent rectangular value, that lets us know what equation to start with. So taking the same equation we have, x is equal to square root of t, and y is equal to 2t plus 3, we know, again, we want it to be y is written as a function of x. So again, step number 1 is to take the x is equal to square root of t and solve for t again. To undo a square root, you should square it. Going to the second part, where we want to write y as a function of x, where y is equal to 2t plus 3. We want to change the t in for an x, so that means that y is equal to 2x squared plus 3. And last but not least, we got to change the domain or the parameter. From t to x. Now remember, we already know what t is equal to. T is equal to x squared. So if I take the square root of both sides, I would get the parameter for x to be 0 is less than or equal to x is less than or equal to square root of 8 or 2 square root of 2. Problem, again, it says to graph the plane curve given by the parametric equation x is equal to t squared, y is equal to square root of t, where the parameters of t is between 0 and 4. Using your graphing calculator, plug in the y is equal to. Make sure you set your window correctly. Take a look at the table to see what the ordered pairs look like, and then take a look at the graph. Because the function is written where it is going parallel to the x-axis, that is a giveaway to say x is equal to a function of y. The reason why it's important for us to find the equivalent rectangular equation, that means the first thing we do is take the y equation and solve for t. So with that, let's go ahead and change the parametric equation into the form of x is equal to f of y. We can do that by taking y equals to square root of t and solve for t. So t is equal to y squared. Next, we need to rewrite the x is equal to t squared in terms of y. We have x is equal to t squared. We know that t is equal to y squared. So the function that we're looking for is x is equal to y to the fourth. Last but not least, we got to make sure we change the parameters from t to y. And we know in step 1, we know that t is equal to y squared. And take the square root. And you get 0 less than or equal to y less than or equal to 2. Let's take a look at one more. Same instructions where it says to graph the plane curve. X is equal to 2t minus 1. Y is equal to t squared. Your parameters are between negative 3 and 3. Nothing changes here. We still have the y equals. We still need to make sure we set our window. We still need to make sure we look at the table. And then we take a look at the graph. Since the graph is surrounding the y-axis, that means it's y is equal to f of x. And that's how we need to change the parametric equation to a rectangular one, by getting y by itself in terms of x. You should be thinking step number 1 is to take the x equation and solve for t. Step number 2 is to take the y equation and substitute in what t is equal to. And evaluate it. So the function that we're looking for is y is equal to x squared over 4 plus 1/2 x minus 11 fourths. Don't forget to change the parameter from t to x. And your parameters x is going to be from negative 7 less than or equal to x less than or equal to positive 5.